Okay. Now, let us start with 241. Question number 8. Now, remember, I have randomized the options. One of these is correct, not necessarily A. So you see the options, but you don't see the correct answer until we solve it. The question says that the compressive strength of concrete is normally distributed. So you have a variable X that is normally distributed. The mean is 17,200 and the standard deviation is 345. We are asked to find the probability that is the probability about a single value or the sample mean. If the question is about single value, you solve it from chapter 4 using this formula from the normal distribution. If the question is about sample mean, which is from chapter 7, you will solve it using this formula. Okay, so this question is about sample mean. Clearly, the question tells you that the sample size is 5, n is 5, mu is 17200, sigma is 345, and what are you asked to find? Find the probability that the sample mean strength, is between 17217 and 17325. This is required. Okay, so first convert it to less than format. This is probability of X bar less than upper limit minus probability of X bar less than lower limit. Then convert both of them into Z. So this is probability of Z less than 17,325 minus, what is mu? 17,200 divided by sigma over square root of n minus probability of Z less than 17,217 minus 17,200 over 345 over root of 5. So this gives us probability of Z less than 0.81 minus probability of Z less than 0.11. Now we go where? We go to the Z table, and I will take you to the Z table and look for less than 0.81 and also look for less than 0.11. So when we go to the Z table, what is the area under 0.81? 0.79103. And what is the area under 0.11? 0.5438. So you take these two values and go back and plug it into that expression that you got. So this is equal to 0.79103 minus 0.54380, and the answer is 0.24723, which corresponds to option C. Any questions? No questions. Let's move on to question number 9. A synthetic fiber used in manufacturing carpet has tensile strength that is normally distributed. Mu is 520. I will highlight the important information. X has a normal distribution, number 1. Mu is 520. And the standard deviation is 25. Is this standard deviation for the population or the standard deviation for the sample? How do you know that? Is it the standard deviation of the sample population? How do you know that? Okay. Distribution is population. Remember that distribution is population. We made a diagram in chapter 8. A population on X is modeled by the distribution. So whenever they use the sentence distribution and they give standard deviation in the same sentence, that's the population standard deviation. You will find this information helpful in chapter 8, where you have to choose between a Z and a T based interval. And the only difference between Z and T is whether population standard deviation is given or sample standard deviation is given. And it is very tough to choose between two if you don't know how to decide. Then what's the question? A random sample of n equals 6 is selected and the standard deviation of sample mean is computed. What is the standard deviation of sample mean? Before we get into the question, what is the standard deviation of sample mean? No, not sample standard deviation. What is this? This is standard deviation of X. This is standard deviation of sample mean, X bar. And what is the standard deviation of sample mean? Chapter 7. We said if X follows a normal distribution with mean mu and variance sigma square, then what is the distribution of X bar? It will also follow a normal distribution with its own mean and its own variance. What is the mean of X bar? We said it is the same as the mean of X. And what is the variance of X bar? We said it is the variance of X divided by N. Or in case of standard deviation, it will be the standard deviation divided by the square root of N. You remember this equation? So the mean of X bar is the same as the mean of X, and the standard deviation of X bar is the standard deviation of X divided by the square root of N. Remember this terminology. This is called the standard error of X bar. Because in exam, you will need these terminologies. Let's go back to the question. The question says that you have a variable X that follows a normal distribution. Mean is 520, standard deviation is 25, sample size is 6. Then you compute the standard deviation of sample mean. This is sigma over square root of N. You computed sigma over square root of N. Then you do what? How is this sigma over square root of N changes when the sample size increases? Sigma X bar is actually what? It is sigma of X divided by the root of N. Now, if N increases, what happens to this sigma X bar? Decreases. So select one of the options that corresponds to the correct answer. The standard deviation of sample mean will not change. Will it not change when you increase sample size from 6 to 49? It will change. Wrong option. The standard deviation of sample mean will decrease. Will it decrease? Yes, it will decrease. The standard deviation of the sample mean will become undefined. Will it become undefined? No, it will not become undefined. It will increase. Will it increase? No, it will not increase. The standard deviation of sample mean will be equal to the population standard deviation. Will it be equal to sigma? No, it will not become equal to sigma. So option B here is the correct option. And to answer this question, you need to know that the standard deviation of X bar is equal to the standard deviation of X divided by square root of N. What is the mean of X bar? What if this whole question was about the mean and not the standard deviation? It is equal to the mean of X, same as the mean of X. So it is regardless of the sample size. If sample size changes from 6 to 49, the population mean of the sample mean will be unchanged, not change. Question 10. Suppose that you have 100 sample of size 100 from freshwater lake taken and you note the calcium concentration in those 100 water samples. A 95% confidence interval on the mean concentration is found out to be between 0.52 and 0.74. Which one of these is the correct interpretation of this confidence interval? We repeatedly said in chapter 8, what did we say in chapter 8? That after calculation, once you compute the confidence interval, never interpret that confidence interval in terms of probability. Always interpret it in terms of confidence. Never interpret it in terms of probability. Look at the options. The options say that there are 95% chances that mu will be between 0.52 and 0.74. Is this correct? No. This is wrong. This is the correct answer, by the way. The option is wrong, but this is the correct answer because question is asking you that which one is not true, and A is not true. Why the other options are true, let me explain one by one. If n equals 100 random samples of water from this lake were taken and 95% confidence interval on mu was computed, and this process was repeated a very large number of times, then around 95% of the confidence intervals will contain the value of mu and 5% will not contain the value of mu. Remember, this is correct interpretation. We discussed it in chapter 8. We discussed it in chapter 8 that from this population, if you take several samples, infinite many samples, and compute confidence interval based on each sample, then 95% of those confidence intervals will contain mu and 5% will not contain mu. Option C, if the sample size was increased, the 95% confidence interval width will decrease. Will it decrease by increasing the sample size? This is the formula for confidence interval. This is the formula for the width. When sample size increases, the width decreases, yes or no? Yes. So option C is correct. If the sample size was increased, the width decreased. A 99% confidence interval will be wider than 95%. Is that true? It is true. The given one was 95%. A 90% confidence interval will be narrower than the given interval. Is it true? Yes. So if you increase the confidence level, the interval will increase. The width of the interval will increase. So apart from option A, all the other options are true. But the correct answer is A. Question 11. The lifetime in hours of 75 watt bulb is known to be normally distributed and sigma is 39. Now here the question might not have used the notation sigma. The question might have said that it is known to be normally distributed with standard deviation 39. Even in that case, if the standard deviation is attached with the word distribution, it's the population standard deviation sigma. Suppose that the total width of the confidence interval is 18 hours. The total width of the interval, which interval? 95% interval, is 18 hours. What was the sample size used? We have the formula for n. N is Z alpha by 2 sigma over E whole square. This is given to you in the formula sheet. But the question does not give you E directly. The question gives you the width of the interval. And we know that the width is what? 2 times E, which means E is what? E is 9. So plug it in. 1.96 Z alpha by 2 is given to you in the question. What if it is not given to you in the question? You must find it using this 95%. Alpha is 5%. 1 minus, alpha by 2 will be 0.025. 1 minus alpha by 2 will be 0.975. You go to the Z table and look for 0.975 and the corresponding value should be 1.96. You plug everything in. Sigma was 39. E is 9 whole square, and you get n to be 72.1367. What is the correct answer? you have to round it up. So n is 73. This is the correct answer. B is the correct answer. And you can see that 72 is there in the options. The brightness of television picture tube can be evaluated measuring the amount of current required to achieve a particular brightness level. A sample of 5 tubes resulted in X bar to be 315, S is 15.3. Find a 99% confidence interval for the mean current, mu. What is the lower limit of the interval? Will you use a Z-based interval or T-based interval? T-based, why? No, not because S is given, because sigma is not given. What if you have a question where sigma and S both are given? You will use sigma, of course, you will use the bigger information. So here you are supposed to use T-based interval because population standard deviation is unknown. The interval is X bar plus minus T alpha by 2 with V degrees of freedom S over square root of N. I need all of these components. Many of them are given to me in the question. X bar is given to me as 315.5. S is given to me in the question as 15.3. N is given to me in the question as 5. The only thing I need to get from table is the critical value. What is alpha given to me in the question? 1%. What is alpha by 2? 0.005. This is what's the difference between Z and T. Don't do the last step. Don't do 1 minus alpha by 2 for the T table. For the T table, directly look for alpha by 2. For the Z, look for 1 minus alpha by 2. Let's go to the T table. And from the T table, go to the, what was the degree of freedom? What was the degree of freedom? You need V. What is V? Let me show you how it is given in the formula sheet. In the formula sheet, it is given like this. X bar plus minus T alpha by 2 and V is given to you as N minus 1, right? So your N minus 1 in this question is what? 4. So you will look for 4 degrees of freedom. 4 degrees of freedom and alpha by 2 to be 0.005. So look for 0.005, which is here, and 4 degrees of freedom. And the value of T is 4.604. Very important, 4.604. That's the only thing we are testing in this question. Plug it into the interval. What is the question asking you for? The lower limit of the interval or the upper limit of the interval? Lower limit. So the lower limit is X bar. Let me put the values. 315.5 minus 4.604 times 15.3 over square root of 5. And this will come out to be equal to 283.9977. Which corresponds to option D. Any questions? Number 30. A manufacturer of electronic calculator takes a random sample of 120 calculators. How many calculators? 120 calculators. He finds 9 to be defective. Out of 120, how many are defective? 9 are defective. Construct a 95% confidence interval for the proportion. Last topic of chapter 8. The upper confidence limit is required. So here you are required to construct a 95% confidence interval for the population proportion. Here is what is going to be given to you in the formula sheet. This is a confidence interval for population proportion. P hat plus minus a critical value times P hat. What is this P hat? It's the sample proportion. The proportion of successes from the sample. The sample is given to you that the sample size is 120 and the number of successes was what? It is given to you that the sample size is 120 and out of 120, how many successes? 9 successes. So P hat in this question will be 9 divided by 120, the proportion of defective calculators in your sample. The proportion of defective calculators in your sample, that's P hat. Turn off your mobiles, all of you. Put them in the pocket. Mobiles. In this formula of P hat, this 9 is denoted as X, the number of successes in your sample. And this 120 is the sample size of your sample. So P hat comes out to be 9 divided by 120. This is equal to 0.075. And after that, it's just plug in. You plug in everything into the interval. The formula is given to you, P hat plus minus Z alpha by 2, P hat into 1 minus P hat over N whole square root. You plug it in, 0.075 plus minus, what is Z alpha by 2? A very popular value. At 95%, it's 1.96. Square root of 0.075, 1 minus 0.075 over, what is N? 120. And you are required to find only the upper limit. So I will get rid of minus sign, only with plus. And this will be equal to 0.1221, which corresponds to option D. Yes. What is the question? Construct a 95% confidence interval on the population proportion of what? The question should clarify. The question should clarify that you are talking about the proportion of defectives. This can be another trick that we give you a number of defectives and ask you for the proportion of non-defectives. In that case, you must find the proportion of non-defectives from the sample. So the question should have clarified this one. Valid point. Question 14. A random sample of 90 suspensions helmets used by the motorcycle riders and automobile race drivers, they were subject to impact testing. They tested whether they can take a shock or not. And the damage was observed in 18 of these helmets. How many helmets were tested? 90. The damage was observed in how many? 18. What is the proportion of helmets that that had the damage? And this is equal to 0.2. Then using this point estimate of P, they want us to estimate what? How many helmets must be tested? What is this? How many helmets must be tested? What is required? The yellow highlighted thing is required. What is it? The number of helmets to be tested. N is required. New N is required. Old N is given to you as 90. New N is required. Such that you are 97% confident that the error is what? 0.02. Let me take you back to the formula sheet. This is what, where is it? This is what is given to you in the formula sheet about N when you are estimating the population proportion. N is greater than or equal to Z alpha by 2. Z alpha by 2 will come from 97%. The question says 97% confident. So alpha is 3%. From there, you will get Z. The question gives you the margin of error. Now here you have to decide whether to use P equals 0.5 or to use an estimate from the question. Does the question give you an estimate of P? Go back to the question. I will take this formula and write it here, and then we will see in the question, is an estimate of P given to us? In this formula, now we see using the point, look here, using the point estimate of P. Yes, we are given a point estimate of P, which is 18 divided by 90. So we will use that point estimate of P. The only thing that is left in this question is to get Z alpha by 2. So to get Z alpha by 2, what is your alpha? 3%, good. What is alpha by 2? 0.015. Now you will do that additional step. What is 1 minus alpha by 2? 985. Go to the Z table. Look for 0.985 inside the table. Go to the Z table and look for 0.985. Look for 0.985. Is it there? Where is it? 0.985. 0.98. What is it? 2.17. So we take this value 2.17. Z alpha by 2, 2.17, and plug it into the formula. When you plug it into the formula, it is 2.17 divided by E. E is given to us in the question. Can you find where it is? Margin of error. 0.02, the last thing which is given to you in this question, that the error of estimating P should be less than 0.02. So E is 0.02. Then you take the square. Then here you use the estimate 0.2 into 1 minus 0.2. What if this estimate was not given to you in the question? 0.5. And this comes out to be 1883.56. Will you round it to 1883 or 1884? 84. So the correct answer is option B. Yes. No. Usually you give the upper bound for the error. Smaller error is actually better for you. Usually when you are estimating the sample size, you say that I allow you to have a maximum error of 2%. If you give me an error of less than 2%, it's good for me. This is term 233, question number 8. An electronic company manufactures the resistors that have a mean resistance of 100 ohms. This is mu. And the standard deviation is given to be 10 ohms. This is sigma. The distribution of the resistance is normal, and the sample size of 20 resistors is 25. N is 25. So what is given to you? This 100 is mu of X. This 10 is sigma of X. This is N. And what is required? The sampling distribution of the sample mean, X bar. What will be the distribution of X bar when X is normal? Chapter 7. When X is normal, X bar is normal. So X bar should be normal. Take out this option. This is wrong. When X is normal, X bar is normal. So let's decide about these 4 options. With mean what? This is what you said in chapter 7. If X is normally distributed with mean mu X and sigma X, then X bar will also be normally distributed with the same mean, but sigma over square root of n, right? Now, which one is correct? X bar will have a mean of same 100, but the standard deviation should be 10 divided by square root of 25, which is 5. Standard deviation should be 5. So which one is correct? 100? C. C. So option C is correct. Why A is not correct? What is wrong with A? Mean is wrong. What is wrong with B? Standard deviation is wrong. What is wrong with D? Both are wrong. What is wrong with E? Distribution is wrong. It's not normal. Distribution is wrong. The distribution should be normal. Question 9. The amount of time that a customer spends waiting at the airport check-in counter is a random variable. Distribution is not given to you. Is a random variable. Some distribution. And what is the mean of that distribution? 8.2. And what is the standard deviation of that distribution? 2. Suppose that you take a random sample from this distribution of size 49. Find the probability that the average waiting time, of these 49 customers is more than 540. Reading the question, extracting the information, most important. Once you extract the information, now it is what? Go to the formula sheet, convert it to Z and solve it. So 80% of the question is actually reading the statement, extracting the information that what is given and what is required. What is given and what is required. Now, to solve a question about X bar, what is the distribution of X bar from chapter 7? How can we solve a question about X bar? We said that X bar is either exactly normal, if X is normal, and it is approximately normal, if X is not normal and N is large. Here, X is not normal. You have no information about what is the distribution of X. They say it follows some distribution. We don't know which distribution, but N is large. So in this case, your X bar will be approximately normal with the same mean, 8.2. And the standard deviation will be 2 over square root of 49. So convert it to Z. This will be probability X bar minus mu divided by sigma over root of N 540 minus, one more trick. The question is about seconds and the mu and sigma is given in minutes. So convert the question into minutes. This is probability of X bar more than 540 seconds is how many minutes? 9 minutes. According to the solution that I prepared last night. Is it correct? 9 minutes. So this is equal to 9 minus 8.2 divided by 2 over root of 49. And this is equal to probability of Z greater than 2.8. Can a question of Z be solved in the greater than form? No, you must convert it to 1 minus. So this is 1 minus Z less than 2.8. Let's go to the Z table for practice and see what is the area below 2.8. What is the area below 2.80? 99744, 0.99744. Here it is. .99744. This is the area below 2.80. You take this area, go back to the question. 1 minus 0.99744, and the answer is 0.00256. Any questions? Next question. For a normal distribution with known variance, very important information. With known variance, the confidence level for this interval is what? X bar plus minus 2.14 times sigma over root of n. This critical value for the known variance, you use Z interval or T interval? Z interval. So Z alpha by 2 is given to you as 2.14. And you are asked to find what? Again, a very important point. Significance level or confidence level? Which is alpha or 1 minus alpha? 1 minus alpha. So remember at the end, if you find alpha, take 1 minus alpha before getting to the final answer. Now, how do you get this 2.14 indirectly? Go to the Z table. What will Z table give you? Alpha by 2 or 1 minus alpha by 2? 1 minus alpha by 2. Z table, you always look for 1 minus alpha by 2 and always get 1 minus alpha by 2. Whereas T table, you look for alpha by 2 and also you get alpha by 2. So for Z table, go back to the Z table and look for area below 2.14. That should be 1 minus alpha by 2. And when we go to the Z table and look for 2.14, area below 2.14. What is area below 2.14? 98382. Can you see it? 0.98382. So we take this value, 0.98382. What is alpha? So alpha in this case comes out to be 0.03236. But we're not supposed to give significance level. The question is asking for confidence level. So confidence level will be 1 minus 0.03236, which is 0.96764. In terms of percentage, 96 point. Which one is closest? A is the correct answer. What if this was unknown sigma? And here there was S. You will go to the T table. You will compare this 2.14 with the T table. Just something for you to think. Next question. The diameter of holes of a cable is known to have normal distribution. The standard deviation is 0.01. Is the sample standard deviation or population standard deviation? Because it is in continuation to normal distribution, it is population. A random sample of size 10 gave me the average. This average is X bar or mu? Why X bar? It's from the sample. The average of the sample is called X bar. The average of population is called mu. This is in the same sentence as the sample. A sample of size 10 gave the average 1.5. So this is X bar. What are we supposed to find? A 99% confidence interval. So you know the value of sigma. When sigma is known, how do we find the confidence interval? This is the formula. From this formula, what is given and what are we supposed to find? Is X bar given? This is 1.5045. Is sigma given? 0.01. Is n given? 10. Z alpha by 2. What is given to us? Alpha is given to us, 1%. What is alpha by 2? What is 1 minus alpha by 2? So go to the Z table, look for 0.995. Let's go to the Z table and look for 0.995. Where is 0.995? Inside the table. Here, right? This is between which two values? This is between 2.57 and 2.58, and it's almost in the middle of the two. So I will take the middle of 2.57 and 2.58, which is 2.575. So my Z alpha by 2 will be 2.575. Now plug everything into the interval and you get 1.5045 plus minus 2.575. Sigma is 0.01 over root of 10. And you get the limits to be 1.496357 all the way up to 1.512643. Which one is closest? 496. D is the closest, I think. So D is the correct answer. Rounded to 3 decimal points were the options. So we checked up to 3 decimal points, which one is the closest. Question number 12. An impact test was performed on 20 specimen. 20 specimen. N is 20. The sample mean is this one, and the sample standard deviation is this one. Assuming that the population is normal, the length of 99% confidence interval is what? So to find the length, you need the confidence interval first. Find the confidence interval, then the upper limit minus lower limit will be the length. So in this case, number one, are you required to find the confidence interval for mean or proportion? These are the two things in your syllabus, chapter 8. Confidence interval for mean or proportion? Is it asking you for the mean or proportion? The question is about the mean. Then, when you go inside the mean, is the population standard deviation known or unknown? Sigma is known or unknown? Not known. If it is known, you will go for Z-based interval. If it is not known, you will go for. So summarizing chapter 8, here is chapter 8. Confidence interval. What am I doing? Confidence interval for mu for P. For mu, you have two cases. Sigma known, sigma unknown. When sigma is known, x bar plus minus Z alpha by 2, sigma over root of n. When sigma is unknown, for P, this is the whole chapter 8. 3 cases. So first identify whether the confidence interval is for mean or proportion. If it is for mean, 2 cases. If it is for proportion, forget about any cases. It's simple single formula. For mean, check if population standard deviation is given or not. If given, use Z-based. If not given, use T-based. If it is not given and the degree of freedom is not available in the T table, then what? Take infinity or go to the. Z table. This is whole chapter 8. So let's go back to the question. The question is about mu, and the population standard deviation is not given. What's given is what? Sample standard deviation. So the given information to you is that n is 20, x bar is 1.25, s is 0.25, a 99%, that means alpha is 0.01. So you will go to the t table, alpha by 2 will be 0.005. You will go to the t table and look for 0.005 against what degree of freedom? What degree of freedom? V will be 19 and minus 1. And that value will be 2.861. I will not go to the t table now. And you put everything into the confidence interval. It should be 1.25 plus minus 2.861 multiplied by 0.25 over root of 20. This will give you an interval 1.09 all the way up to 1.41. The difference between 1.41 and 1.09 is what? It's the length, and that will be 0.32, which is option B. Next question, quickly. The lifetime of same question, normally distributed with variance what? Standard deviation will be what? 15. Is this sample standard deviation or population standard deviation? Population. Sigma is 15. If we want the error in estimating mean life, this is the question about mu. If we want the error to be, where is the error? If we want the error in mean life for 3 hours, here is the error. E equals 3, alpha equals 0.05. What is the sample size? N is Z alpha by 2 sigma over E whole square. What is Z alpha by 2? 5%. 1.96. What is sigma? 15. What is E? 3 whole square. This gives me 96.04. What is the answer? 97. Last question. The fraction of defective. Fraction is proportion. The fraction of defective integrated circuits produced this. A random sample of size what? N is 350 is tested, revealing how many non-defective? How many non-defective? 336. The question is about what? Defective. And the statement is about what? How many are defective? X is 14 here, not 336. P hat will be 14 over 350. And this comes out to be 0.04. Then they are asking you to find a 95% confidence interval. Alpha is what? Z alpha by 2 will be what? And the confidence interval is P hat plus minus Z alpha by 2 P hat into 1 minus P hat over N square root. This will be 0.04 plus minus 1.96 square root of 0.04, 1 minus 0.04 over 350. And this will give you 0.0195 and 0.061. Which one is closest in terms of percentage? A is closest. No, this is 0.06005. 0.5, what happened? Zero 0.5. So A is the correct answer in terms of percentage. This is the end of 233. We solved 2 exams, 241 and 233.